Hi guys, welcome to my channel. Please, before we start, it's also good to subscribe, like, share, comment. Subscribe, it doesn't bite. So we're looking at differentiation. Whenever we talk about differentiation, we're talking about change. Change of one quantity with respect to the other. And differentiation has numerous applications in science. Like talking about velocity. Velocity is simply defined as change of displacement with respect to time. And that velocity can be written as ds dt. Now, to start differentiation, we'll start by looking at differentiation from first principles. And to differentiate using first principles, we have here dy dx is the limit of f of x plus delta x minus f of x divided by delta x. And this delta x is an increment. It's an increment in x. So talking about delta x, we're talking about an increment in x. H can equally be used. Okay. So examples. Find dy dx from first principles, given that y is 5x plus 2 and y is 3x squared plus 6x plus 2. Now, we have our function here, given f of x equal to x plus 2. We need to obtain the numerator f of x plus delta x, which we substitute, which means we are looking for the image. We take this, we substitute in this our function. And when we substitute that, we have 5x plus 5 delta x plus 2. Now, looking back at our formula, we need to have that numerator. And the numerator here be evaluated. We have 5x plus delta x minus f of x. That's f of x plus delta x minus f of x. When you subtract, you see 5x here minus 5x 0. 2 minus 2 0. We are left with 5 delta x. So dy dx from first principle is the limit of delta as delta x tends towards 0 of 5, our numerator 5 delta x over. Looking at the second example that we have here, y is f of x equal to 3x squared plus 6x plus 2. So we can still choose to use h, that's the slight increment to be h. So we have f of x plus h. We substitute the image of x plus h at the place of x here. We have x plus h, all that square, plus 6 into x plus h, plus 2. Okay, when we expand x plus h, all that square, we have x squared plus 2xh plus h squared, plus 6x plus 6h plus 2. Now we have 3x squared plus 6sh plus 3h squared plus 6s plus 6h plus 2. When you subtract now the main function, we have f of x plus h minus f of x. So our f of x, we subtract this. So you see that this 6s we cancel. We'll be left with 6xh plus 3h squared plus 6h. This is it here. Now applying the formula there, the limit as h tends to 0 of 6h xh plus 3h squared plus 6h. When you do this, you have h common factor, cancel, we are left with 6x plus 3h plus 6. As h tends to 0, 3, you replace h with 0. 3 times 0 is 0. So we have our answer 6x plus 6. So you see that in general, if you have a function y is kx to the power n, then the derivative will be n kx to the power n minus 1, where k, n, and c are constants. Because looking at this our function, if you are to use the rule method now, you will see that if I take 2 times 3 give me 6, and I reduce the power by 1, you have 6x, and this is the 6x. This is the 6x here. Now if you take here 6x, the power is 1. 1 times 6 will give 6. X to the power 1 minus 1 is x to the power 0, which gives 1. 1 times 6, we have our 6. Okay. Alright, thank you. And before I forget, we also have that the derivative of a constant is 0. So if you are applying it here, you see, if I have to differentiate y equal to 3x squared plus 6x plus 2. 2 times 3 here will give us 6. The power reduces by 1. So we have x to the power 1. The power here is 1. 1 times 6, 6. The power reduces by 1. 1 minus 1, 0. We differentiate a constant, it will give you 0. So we are left with 6x plus 6. Thank you.